Thank you very much for coming to this session about KubeBoot. I mean that KubeBoot is not a tool. It's just a way to say that we're going to see how we can deploy our Spring Boot applications smoothly into Kubernetes. My name is Alex Soto. I work in Red Hat. I'm the curator of lordofthejars.com. And, well, I'm the co-author of Testing Java Microservices. Also, I've recorded some courses for open webinars. And, well, these are ref cards and so on and so far. But it's not so important, this at all. This is the book. If you are interested in knowing how to test microservices, then it was released like 3 or 4 months ago, so it's quite updated. If you have any question, please just raise your hand, and I will try to answer it as soon as, that during the talk. Don't wait until the end. I mean, that you can do it, because at the end we will have time for questions, but if you can do the question under the context, then it's better. And just one thing, some people ask me, what are you showing today is open source. A lot of people ask me this several times in several sessions, and I said, yes, everything that I'm going to show you here is open source, it's Apache licensed version. Everything that we do in Red Hat is open source, right? So anything that you see under the Red Hat brand is open source. And I know that some people are thinking about this IBM plus Red Hat thing, right? I'm not here to talk about this, but just let me tell you one thing, that open source is in the DNA of Red Hat. So no worries, everything in Red Hat will be always open source. So this is a microservice, right? Nowadays, most of us are moving to microservices architecture, and this is how a microservice looks like, right? That we have like my service, my business logic, can be implemented with several languages, Node, Spring Boot, or Redux. And then, because of network, because all our microservices communicates through network, appear all these cross-cutting concerns. For example, there is discovery. We need to know how to discover each of the services. There is the API, which defines how we connect with this service. There is an invocation, how we invoke other services. There is the elasticity, right? What's happening if we have an amount of traffic during, I don't know, several hours? Then we need to scale up and down our services. There is a resilience, what's happening if my service goes down. I need to be able to recover quickly and automatically. There is a pipeline. Each of the microservices should be deployed automatically into a defined pipeline. Now, there is also the authentication problem, right? I mean, now we have several services, and we need to know how, when we call from service A to service B, knows that the B knows that it comes from the real service A and not another one, and even the authorization problem with the users authenticated on our system. So authentication is something quite complicated in microservices. Then there is the logging. In a monolith, it's really easy, right, to log because it's just a file. But now we have several services, and we need to find a way to merge all these logs together. There is the monitoring. We need to know what's happening inside our cluster. And finally, there is the tracing thing, which is like, what's happening in a request when it goes into my architecture? How it travel across all the services, and how much time takes in each of the stages. So it's all these kind of things appear because of microservices. And what's happened nowadays is that then we have this, what it's called Netflix OSS, right? Which is like, for example, Orica, Ribbon, or Chaos, Zool, and so on, Istio, for example, for circuit breaker. And what we end up is just having our Spring Boot application, and then all these libraries inside our service as well, right? And it means that you are polluting your class path, because all these projects has dependencies and transitive dependencies, so our class path is polluted with all of them. And even one thing that is worse is that all these libraries has an impact in our service. So we are not implementing just our service, but also we are implementing all these cutting concerns inside our logic. And finally, when we have all these libraries put inside our Spring Boot application, then we put it inside a Docker container. And why you put it into a Docker container? Well, I mean, I think that Docker doesn't need any introduction, but it's really awesome what Docker offers you. because it allows you to define your stack. I mean, you define which operating system you're going to use. You define the virtual machine, and this is quite important. I remember in a project that I work where we just have JDK 1.6 minus, and then some number, right? And this was in all the environments except in production, which was like 1.6.0 as well, but it was another minor version. And then when we deployed to production, we started getting some failures because of security things. I mean that we use heavily crypto, and then crypto changed it from minor to minor version. And then we had problems in production, but not in pre-production or in developer's machine. So it's really important to define correctly in all our environments the JDK, and this is something that Docker allows us pretty well. Then there is, you can even define your custom configuration like JDBC drivers, JMS queues, users, and so on and so far. And finally, it's your jar, right? It's like your service. So defining this allows anyone in the company to deploy to production, because you don't need to know anything else rather than said, okay, this is my container, and I need to just run Docker run, blah, 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 and then my service will boot up with everything inside. And thanks of Docker, these are really different thing of what we've worked before, where maybe you have a WAR file, and then you should send an email and saying, look, you need to take this WAR file and copy it to, I don't know, web apps folder in this server, and then do all these things manually, and knowing that each of the project deploys in a different way. Thanks of Docker, this is standardized. Every project is deployed in the same way. But with Docker, we have some problems. And it's like how we scale. So, okay, you know that you can run Docker run on a machine. This machine might contain Docker host, and then the container is up and running in that machine. But how we make it to have it in different machines. How to avoid port conflicts. Of course, at the end, there are physical machines, which there are ports. So how we avoid that several services tries to use the same port. What happens if a host is in trouble? What happens if my Docker host stops working? What I can do? How can I keep them running? How can I update them? At the end, it's like there are some questions, right? I mean that Docker is awesome in the developer machine, but when we move up to production, then we might have problems. So one option is just, if I have 3 machines, then I just do SSH to the first machine and do Docker run, and then to the second machine, and then to the third machine, SSH Docker run, and my container, and then, yeah, of course, I can script this, but I have everything deployed automatically. But of course, this is not the way of working, right? I mean that the solution is Kubernetes. I mean that I would say that Kubernetes is the de facto tool if you are into the Docker containers nowadays. And just as an introduction, Kubernetes means helmsman, the pilot of the ship, and that's important, right? Because with Docker, we have all this whale and ships and so on and so far. Then we need a pilot for all of these containers, and this is Kubernetes, which is a container orchestrator. And it works in several multiple clouds and bare metal environments. In fact, all these demos runs on my machine, so it's bare metal. And it's inspired by Google Experience and Containers. It's open source, it's written in Go, and allows you to manage applications on non-machines. And this is really important because with Kubernetes, you only say things like, I have my service, and I want 3 instances of my service in the cluster. And that's all. You are not managing machines anymore, which is really great. And a Kubernetes cluster looks more or less like this, which we have the developers and the ops guys who can interact with the master. The master is the one who have the API, etcd, scheduler, and controllers, which basically is like the entry point for sending requests to the cluster. And then we have several nodes, right? These nodes can be bare metals or virtual machines, and each node has one thing that is called minion, right? Which is like, somehow it's like an agent, right? That is checking constantly if the node, if there is any application in the node that it's behaving abnormally. And if it behaves abnormally, then it just shut down and start up again, right? And then it's just, several machines there, and you said, I want 3 instances of my Tomcat application, and then it just replicate my application through several nodes. So it's really easy, let's say, to deploy something on a Kubernetes cluster and have your application scale up correctly. And I mean, there are a lot of concepts in Kubernetes, right? But maybe these ones are the most important. Well, the first thing is a pod, and it's important, the definition of pod, because a pod is more than one container. Usually people, when you explain about pod, they say, okay, so I have my Docker container, and then I have a pod, and then I have, you see here, replicant controller service, and so on and so forth. But it's not entirely true, because pod, by definition, is a group of whales. This is the definition of pod. So if you think about Docker container and whales, which it's like every container is a whale, since a pod is a group of whales, it means that a pod is a group of containers, which share the IP, share the storage volume, share the resources, and share the life cycle. This is the pod. It's the basic unit. This is where you define your container image. And then we have the deployment, or deployment replica controller, which is the one who ensures that the number of pods that you want to have in your cluster is always the required number. So for example, you said, I want 3 instances of my container running in the cluster, then this replica controller checks periodically if there are 3 instances running. And if one is not running, then it just starts a new one. And they always take care of having the same amount of instances running there. And then there is service. Like we said here that a pod is a basic unit which share the IP inside the containers. But then what's happening if I have 3 pods of the same service? Each of these pods will contain different IPs. So how can I get it from outside of this service, get it inside the service? And it's like using this service concept, which is like a group of pods, which have a stable virtual IP and DNS name. This means that I can just refer to my group of pods with a service. So when I go to this service, this service is acting as a load balancer and saying, okay, I have 3 instances of your service. I'm going to start by default a round-robin strategy to just redirect the traffic. And finally, we have labels, which are like key value pairs associated with Kubernetes objects. So you can do things like, this service is for the environment production, but another service is for pre-production environment. And then I can start sending traffic depending on these labels. So how we can deploy something to Kubernetes? Well, this is a Node.js example where basically this is my business logic, really simple one, I know. Then you need to create your Docker file, which basically is like, okay, I compile my application. For example, in case of Java, you create your jar file, and then you need to create your Docker file with all the exposed port and the base image and so on and so forth. Of course, when we have this image, we need to deploy. Actually, it's not deploy, sorry. It's upload this Docker container inside a Docker registry. So it's like something like, okay, I do a Docker build, and then I need to do a Docker push to some Docker registry. Now we have our container inside the Docker registry, which is, you can reach it from the cluster. And then we need to define a Kubernetes file. I mean that this is the Kubernetes file where you define things like, this is deployment, my application, it's called hello. I want, for example, 2 replicas. So it means that it's going to start 2 replicas of this service inside my cluster. And then I said that my container is hello, has a name hello, and it's named hello node v1, and then it exposes this container port, which is the 80, right? So you need to go and write all this file. And then when you have Docker file created, Kubernetes file created, your Docker image created, Docker image inside the Docker registry, then finally, you can do kubectl, apply -f, hello deployment.yaml, and then your application is deployed to Kubernetes, right? This is one way of doing it. But today I'm going to show you another way. I'm going to introduce you a project which is called, Fabric 8 Maven plugin, which as you can expect, it's a Maven plugin which allows you to automate all these kind of things. So I'm going to open this project. See that it's a really simple project, I know. But the thing that I want you to see is that there is no There is no Docker file, there is no Kubernetes file, it's just a simple Spring Boot application, which, well, it's just, you know, it returns Monkey Island as a game. It's a really simple one, but it serves as purpose. And then I can go here and I can do maybe a Spring Boot run. And it just start locally this service, which is pretty simple. And then I just need to go to here, and I can go to localhost 8080. And of course, it returns Monkey Island, right? It's just, you know, running locally on my machine. And here there is no Kubernetes at all. But now let's see how we can move this service really smoothly to Kubernetes cluster. The first thing that we need to do is just add the Fabricate Maven plugin, which it can be done by just doing this call, which is Maven, and this is set up. And well, I mean, it seems really magic, but it just, if you check here the code, you see that it just added here a new plugin, which is the Fabricate Maven plugin with some gold. This is everything that you do. And then it's time to create the Docker image, push it to the Docker registry, and create the Kubernetes file, and do the kubectl apply. But as I said, I'm not going to create anything about this. I'm going to do a clean package, fabricate resource, fabricate deploy. So what's going to happen here is like, okay, I'm going to compile, run the test, and this plugin is going to create automatically the Docker file. It's going to create the Docker image, it's going to push it in the Docker registry, it's going to create the Kubernetes file, and it's going to deploy, because I did fabricate deploy goal, it's going to deploy to my Kubernetes cluster. I know that it's quite opinionated, right? But, I mean, in 90% of the cases, it's enough. But what's even important about a fabricate is that you can create fragments. So for example, you can say, well, notice that it's already deployed. Yeah. But what you can do in Fabricate Maven plugin is just say, okay, look, the defaults are fine, but I want to create a config map with some configuration parameters. So I can create a fragment containing only the config map definition. So you have my config map definition on my project, and then it will take all the defaults plus this fragment. And the same happens with the Docker file. You can say, it's fine with the default Docker file, but let me add these environment variables in the creation of this Docker file. And then if I do, I can go here and I can do a kubectl get pods. And you'll see here, this is the games, which is the one that I've deployed now, which is like 57 seconds ago. And if you want to see how this works, I can wait. I've lost again. No. This is well, this is OpenShift, but at the end, OpenShift is like Kubernetes for enterprises. I mean, as you said, I've done kubectl get pods, and it gets all the pods. So it's same. Here is deploy it, and I can go here, and of course, I get it Monkey Island as well. So notice that I've not done anything at all. I've just not created any Kubernetes files, any Docker file, nothing. And I have here my service deployed automatically. Which, I mean, that if you compare it with all the manual steps that you need to do, then with you're not using FMP, you can move it really smooth to Kubernetes. But we also, I mean, there is also a Spring Cloud Kubernetes, which Spring Cloud Kubernetes integrates service discovery. So, for example, you can inject a service using the Kubernetes service name. So then you just use the typical auto-wire it, and then you said, okay, I want to auto-wire this service which has this name, and then you get it all the invocation things done. Also, you can use config map as property source. If you are a Spring Boot developer, you already know this, that you can do a property source, $, and then you have a .properties file, and then this property is injected automatically inside your class. But it works exactly the same for config map. So you can just define a config map and then annotate your property with this key of the config map, and then you will have injected there the value of this config map. And then there is also the Zipkin service discovery, which is by basically using Zipkin with Kubernetes for distributed tracing. So if you see, this is how everything was before Kubernetes. But now, if we move to Kubernetes, what you see is that all the Ribbon, Eureka, and config server is managed by Kubernetes. So you can read off these libraries from your service. Of course, if you want to see here, you see that with Kubernetes, we are covering discovery, invocation, and elasticity. And if you are even using, for example, OpenShift, you have the pipeline, the logging, and the monitoring also covered. It means that now we still have this resilience, authentication, and tracing problem, right? But at the end, okay, we have covering most of the things. But you've seen my example, which was pretty simple. It was just, okay, it's a hello world, right? At the end, it's like Maven clean package, fabricate resources, fabricate deploy, and it deploys a hello world application, which is nice. It works, always works, right? But remember that the job of a deployment pipeline is to prove that the release candidate is unreachable. So let me show you how you can deploy with fabricate a more complex scenario. And well, there are several ways, right, of deploying application into Kubernetes, and several strategies. One is this blue-green deployment, which basically means that you have two identical environments, and then you balance when one of it is ready. So what you have is something like, I have my build in the CI/CD system, then I have in production, all my public traffic goes to the blue service, and then what I do is just, okay, I have my new service, I put it on the green environment, and then I just switch the traffic from blue to green. Then you monitor if everything works as expected. And if you see that, yeah, there is no errors, everything works as it should be, then it could be, could let the green environment be the public one, and then you can remove the blue one. But if, for example, you detect any problem, you said, okay, we've deployed a new service, but it's not behaving very good, then when you can just like switch back quickly to the blue one, and then you can just remove the green and check what's happening, right? So your users, let's say, that will not notice, or the downtime will not be so long if you have done this correctly. But of course, as you've seen, in the previous strategy, it was an all or nothing, right? It was like, okay, all traffic goes to green, then I switch to blue. If blue goes wrong and there is something wrong, then all my users will receive errors. Then the other strategy is a Canary Release. Basically, I don't know if you know why it's called Canary Releases. Everyone knows why it's called Canary Releases? Who don't know it? Okay, you don't know it? Okay, Canary Releases comes from the mining, yeah, this is the mining thing, yeah. But basically, in the past, they take literally a bird into a coal mine, right? And inside the coal mines, there was some poison gases. The good thing is that, or not, is that a human dies after 2 minutes of breathing these poison gases. But a bird dies after 30 seconds. So this means that all the miners go with this bird inside the coal mine. If they say that the bird was dead, then they know that they have like 1.5 minutes to just go out of the mining. So this is why it's called Canary Releases, because we're going to do the same, not with a real bird, but with a software, right, or a service. So the idea is like, I have my environment, which is the blue one, and I have my service that I want to deploy. And then what I just do is like saying, okay, first of all, one person for example, of my users is going to this new service. And the rest, 99% of the users will go to the old version. And they just say, OK, let's say you move this 1%, and you start monitoring your new version. If your version behaves as expected, then you said, OK, it seems that it works. Let's increase to 10%. And you monitor again. If it works as you expect, you increase to 25%, 50%, and so on, until you get it, that's 100% of the traffic going to this new version. So as you can see, instead of just releasing at one step, you're just step by step releasing to the public. And that's fine, but if you think about, for example, 1% of the users, if you are Facebook, for example, it's a lot of people, right? So 1% of the users, if there is an out stage in this new version, it's a lot of users. So what there is like dark launches. Dark launches is another set of techniques for releasing to a production. But the different thing here is that you can release to public, but the end user will never notice it. It is a big difference, right? If you compare with Blue-Green or Canary. And there are several strategies, and I mean that we have just one talk just talking about dark launches, but just in summary, there's one way of doing it, which is this one, which is like, I have the users, I have the router, and all the public users goes to my production environment, which is the green one. Then I deploy a new version, which is the blue, and then I make that my employees just go to this blue version, and they test it. Depending on your business, this is impossible, but if you think, for example, if you're a bank, or if you're, I don't know, this is a technique that comes from Facebook, right, which like all the employees has Facebook, and then when they detect when an employee connects to Facebook from his workstation. And then when they detect, oh, look, this is a workstation that is inside my network, I'm going to redirect to a new version. So all of us are going to the old version of Facebook, but the employees are testing the new version of Facebook. So then you can monitor your new version without affecting the public users. This is one way of doing it. Another way is like shadowing traffic. Shadowing traffic is like, it's called shadow traffic or mirroring, which is, like the name said, is mirroring your traffic in the next way. Now the blue is the old one, and then the all users, your public users, send a request to your service, and then this service mirrors the request. And mirror request to the blue one and the green one. But the difference is like that the blue one, it's a request, it makes whatever it needs to do, and then it returns a response, and this response goes to your user. So in this sense, your public users will always go through the old version and will receive the old responses. But since you are mirroring the request and you're sending also the request to the new one, you are just doing a fire and forget request, which is like, I send the request, but I don't care about the response. In this sense, you can just start monitoring your new version with real traffic, and your users will never notice that they are used for testing your new version. So, as I said before, with Hello World, this works pretty well, but maybe you're wondering, that's pretty nice, but what's happening with my data, right? Suppose that I'm here, for example, doing a blue-green deployment, which is the easiest one, right? And I have my old version, and I have a shop, and then my users are shopping, for example, movies, and then I just do, OK, and now I'm going to switch to green. And then what's happening with my movies, right? Because I was in the old version, and now in the new version. And this is what in-memory data grids solves. In-memory data grids is like, you can think about like a key value a structure that resides in memory, full in memory, and it's synchronized across the cluster. And well, there are several ones, but what I'm going to show you here is InfiniSpan, which works really well. Let me show you in a demo. I have here, I have deployed these popular movie data stores with 2 pods. Okay, so I have 2 instances of my service deployed. I can go here, okay, and here are all the movies. I mean that this just through internet. And okay, do you want to buy Ant-Man and the Wasp? No? Yes? Okay, no. And then, Mission Impossible? Yes? Okay, let's add this one. Well, I don't know. Bohemian Rhapsody? Yes, okay. Venom? Yeah, okay. Okay, well, I don't know if you... Incredibles? Yeah? Okay, let that Incredibles. Then if I go here in my cart, okay, what you see is that all my movies, and here, you see an important number. You see this number? This is the pod host name. I mean, at the end, a pod has a host name. If I go to here, and I do well, you can, wait, it will be easier this. See this? This is the pod's name. This is one pod. This is another one. And if I check, here you see that this is the 92, which is this one, right? This means that the request of adding all these movies has been served by this pod. So the other pod has no clue about what the user has been created. Then, let's do a blue-green deployment, right? This is, for example, blue. And then I'm going to release a new version. Okay, now I can go to movies. I can open it. And then I'm just going to do one small change. For example, I think that here is the cart. I can to do something different. My movie cart, I'm going to change this to my new movie cart, okay? And then I can go here and I can just do Maven W. And then I do clean, fabricate, deploy. So what I'm going to just do is clean, package, create the Docker file, create the Kubernetes files, and then deploy this to the Kubernetes cluster. So it's exactly the same that before, but with a more complex example. In this, notice here that it's validating and creating a lot of things. And if I check, for example, here, wait. Here, maybe you cannot see, but this is that. You remember that I said that it's pushing the containers to the Docker registry. Here is where the push things happen. And now it seems that it's deployed. And now I can go here. Yeah, sure. Yeah, because it reads the .q folder. You know that there is this folder where all the login information is stored. It reads this. It takes from there. You can even configure it in the configuration side of the plugin, right? But by default, it goes there and it takes all the information from. You have not seen it, but I did it OC login before that to just fill all this file. I mean, this is And wait. If you check here, now you see that I have, wait. Okay, I have, what's happening? Oh man, I've done something wrong. Okay, demo time. Wait. What I'm doing now, well, it doesn't matter. It will work as well. I mean, now I'm doing something strange, right? Which basically I'm doing is just, in theory, is changing. I mean, I'm not doing a real blue-green. because I miss one. I have one Maven profile which is like, okay, I want to switch from blue to green, and now what I'm just doing is just replacing the old version to the new one with downtime. But it doesn't matter. For the sake of the demo, it works. Remember that I said that it was. If we check here, the important thing here is that the movie is served by the 92. I mean that the pod end with 92, right? And then if I do here a kubectl get pods, you see that there is another pod, which is this one, which is running, and this is ffmg4. So the pod, you see here, that the pod 92 is not even in my cluster anymore. But remember that I put all my card inside this pod. And now, but now I'm not sure if it's going to work at all. If not, no. Let me try it. Let's see if it works or not. No, it's doing. I'm not sure. Yeah, notice that now the pod is another one, right? It's not the 92 anymore, but my card is still here. And this is because I've been using InfiniSpan to synchronize all my cluster. So it's a really nice thing that you don't need to worry about anything. Everything is managed by InfiniSpan and Fabricate. So with Fabricate Maven plugin, you just said, okay, I don't want to take time on releasing and generating Docker files, Kubernetes files or whatever. It doesn't matter. You just want to do Maven Fabricate deploy, and they take care of everything. And then, if under the covers you use InfiniSpan, you don't need to worry about maintaining the state of the cluster. Everything is done automatically. This example is in my GitHub, so I mean that you can check it internals, because at the end it's like every time that someone adds a new thing in the card, I just use the InfiniSpan API to say add this to the to the in-memory data grid. Okay, now we are almost done, but before that, I want to show you another thing that probably most of you have already start knowing, and I mean that I have several clusters on my machine. Now I'm starting another cluster, which it's prepared for this next demo. So this is the demo, and then you see that the future is something like that. So you can have like here is the OpenShift logo, but it's like Kubernetes or OpenShift. Then notice that here at the on my left there is Istio logo, and now Istio makes you to remove everything. All these cross-cutting concerns are just removed from your application. So you just have your Spring Boot application. You don't need Eureka, Ribbon, Zool, even, I mean that open tracing is like, well, I mean that it's automatically provided by Istio. You don't need Istrix anymore, and you just need to take care of implementing your business logic. And this is Istio. Basically, it's removing the cross-cutting concern from our business code. And Istio is a service mesh, and a service mesh is a dedicated infrastructure layer for making service-to-service communication safe, fast, and reliable. Okay? And then we're going to see, this is before Istio. I remember that I said that you have the service A with all these cross-cutting concerns like discovery, load balancer, resiliency metrics, tracing, all these things as with your business logic. And then we have the JVM, we have the container, and then I have that the service A communicates with service B, and service B communicates with service C. And each of these services has always all these cross-cutting concerns that basically you end up by doing copy-paste from service to service, right? But when you are using Istio, you have something like this. You have, remember the concept of pod? Pod is more than one container. So what I have is like one container, which is my service, and nothing else. My service, no more cross-cutting concerns. And then I have another container, which is a sidecar container, which is an Envoy proxy. An Envoy proxy, basically, what it does is like manage all the network traffic. So what you are doing is like, instead of making requests from service A to service B, what you're doing is request from service A to this envoy proxy. This envoy proxy will do another request to the envoy proxy of service B, which at the same time will do a request to the service B, right? And then this envoy proxy does things. What things you can do with Istio? For example, routing and load balancing control. So you can define a Canary Release saying, I want 1% of the traffic goes to service A version 1, and 99% of the traffic goes to service A version 2. You have observability. By default, without doing anything, you have Prometheus, Grafana, and OpenTrace up and running for all your services. You don't need to configure anything. It just works. There is also, you can do chaos testing. And one of the great things that our customers in, our customers in Red Hat really loves is security options. You can do things like, okay, I have my service A and service B, and this service A and service B communicates with HTTP in my code, but the real communication happens with HTTPS. And Istio takes care of all the certificate management, all the revocations, all the CA authorities, everything. You just do an HTTP call to the envoy proxy, and this envoy proxy will change this HTTP to HTTPS and do the communication through other service with HTTPS, which is really nice, right? Because if you think about how painful is the communication with HTTPS in Java, that you need to, register the CA authority, all the certificates thing, and so on. It's like, it's always, it never works, right? And you just end up by saying, allow and save. But with Istio, you don't need to take care about this. It's done in the infrastructure level, not at your code level. And for example, it allows you to use JWT tokens. So when you send a bearer token, a JWT bearer token, then Istio will go to your, for example, your Kcloud identity management, or your identity management at the end. It will check the token. It will validate if it's valid, if it has not been dumped. And then it said, yes, OK, your token is valid, and the signature is valid, is validated. And I said, OK, now let's get it some information from the token, for example, your group, and say, OK, you want to do a communication from service A to service B. Service B can only be reached by group administrators. So I'm going to take the group field from the token and check if you are an administrator. And if it's true, then I will let you communicate to service B. But if not, I will block the communication. And all this logic that usually you put it on your service, in your logic, is managed automatically by Istio and Envoy. With Istio, we have like 4 big concepts. The first one is destination rule, which allows you to configure the set of rules to be applied when forwarding traffic to a service. Basically, you define circuit breakers, load balancers, TLS settings, for example, defining subsets of services. And then we have virtual service, but they call virtual services because they are virtual. There is no registry. It's not a service in the Kubernetes object way. It's just something virtual. And it describes the mapping between destinations. Then we have the service entry, because by default, service meshes and Istio does not allow traffic goes out of the mesh. So if you are a service that you want to communicate to Twitter, you can do it. Istio will block this communication. So you need to create a service entry saying, look, you cannot do anything, and you cannot do any external request, except if you're trying to reach Twitter. And then, please let the request go out. And finally, we have this gateway, which is like a load balancer to get into the service mesh. So at the same time, you don't, by default, meshes doesn't allow outside traffic goes inside the mesh. So you need to specify a gateway to say, let this traffic goes inside. Let me show you really quick demo about this. Here, OK. Here, wait. OK, now I have everything in place. I can do a call. And basically, now what I have, what I have here is like I have 3 services, customer, preference, and recommendation. And in the recommendation, I have 2 versions, version 1 and version 2. Then every time that I do a call, by default, I'm just switching between V1 and V2. Notice that it's just taking from customer V1 that comes from one pod, and customer V2 that comes from another pod, and then V1 and V2 and so on and so forth. So it's like a round-robin approach. Then suppose that I want to say, okay, I want to send 25% of the traffic to version 1 and 75% to version 2. The only thing that I need to do is just do an IstioCTL, which is like kubectl, but for Istio. And define here, I have some files defined, which is one that I have here is like, it's over there. In this case, no, it's 75% to V1, 25% to V2. I apply this. Sorry, I miss create. And then I created this new rule inside my mesh. I can show you virtual service, recommendation, V1 here. Okay, now you can see that this is a virtual service which I'm defining a route to recommendation service, which I want to send a 75% to version 1 and 25% to version 2. So I just have this file. I just did it IstioCTL create blah, blah, blah. And notice that I have not deployed anything. And now I can start doing calls. And you'll see that, wait, okay. Get virtual services. And okay. Then CTL, let me CTL create -f the files destination rule. Okay, and now IstioCTL replace -f. It was here. Okay, let's try it now. Okay, now. Now, notice that 75% of the time I go to V1, and 25% I go to V2. Notice that V2 takes more time because there isn't a sleep in the service, so you can get it the difference. But notice that in average, it's like 25, 75. But I've not deployed, changed anything on my services. We can, for example, do more things. For example, I don't know what's happening with this. IstioCTL, create and replace -f, Istio files, and now, for example, I can send all traffic to V1. I can just replace the previous virtual service definition to this new one, which is like 100% of traffic to V1, and now, of course, if I do a call, I get it all the time, just V1, without any change. So notice that how awesome is Istio. And Istio is already supported by FMP. I mean, not in the creation of the files, but yes, in the creation of all these proxy things. So let's wind down. Now with Istio, we have covered everything. Thanks of Istio, we are also covering the resilience because Istio adds support for circuit breaker. Also for authentication, I explained you all this JWT integration and MTLS, and also tracing, because it has for you, out of the box, open tracing installed. I know that's really cool, but please be aware of this. I mean that I've know some companies that are getting Istio into place and start doing some kind of, yeah, we're going to use Istio and start doing Canary releases and we are going to break down our monolith to microservices and so on and so far. And then they do all these things, and then they die, right? And this happens because before doing all these advanced deployment techniques, you need to have a real CI/CD deployment pipeline. And before that, you need to do everything automated, for example, in Kubernetes. And before that, you need to have a good self-service on-demand elastic infrastructure as code. And then you need, first of all, you need to reorg to DevOps. Notice that a lot of people say, yeah, we are in the DevOps, and then we are going to do microservices. Well, this is not a very good thing to do, because there is a lot of steps in the middle. But even, like some people that says, yes, but we have everything automated. We have CI/CD. We are using advanced deployment techniques, so we are fine. But when you said, OK, and if I'm a developer in your company, and I need a virtual machine with PostgreSQL installed in a production-like environment to make my tests, how much time it takes? And some people said, well, I need to open a ticket. This ticket must be approved. And then after 2 or 3 days, I have my virtual machine up and running, right? And it's like, OK. Well, sometimes it's 1 week or 2 weeks, like sometimes, but usually it's 2 or 3 days. Like, OK, then you are not self-service on the elastic infrastructure as code, right? I mean that as a developer, if I want a PostgreSQL on a production-like environment, it should be like 30 seconds. If not, you are in this stage. It doesn't matter if you have archived the other ones. You are in this stage, right? So there's something to think about it. Of course, I've showed here that everything was doing manually, right? And do Maven calls, Istio calls, and so on and so far. But of course, you need to automate everything in your deployment pipeline. And that's all. This is the slides that are published here. If you have any question, you can find me in Twitter. Also an email. Some people said, hey, but you've put it in your mail. Can I send you an email? Yes, of course. You can send me an email because it's here. If not, I will remove it. And you can join developers.redhat.com, and you will find, for example, Istio tutorial, Istio books, also data migration, free books for data migration from monolith to microservices, and so on and so forth. Thank you very much.